Assalamu alaikum, everyone. Welcome back to Ahmad Farhan's solar system. Today, we're diving straight into a massive, awe-inspiring explainer of space's absolute biggest secrets. We're going to travel all the way from our own cosmic backyard right out to the invisible forces that literally shape reality itself. Have you ever just stopped, looked up at the night sky, and wondered, how big the universe really is? I mean, what exactly lies just beyond our solar system? And maybe the most profound question we can ask: could there be another Earth out there, hiding among those billions of twinkling stars? These are the huge existential questions that have driven us for centuries. All right, part 1, our local solar system, the cosmic backyard. Okay, let's dive right into this. Our journey has to begin at home. You can see the sun and its orbiting planets right here. And what's truly incredible to think about is Earth's specific place in this whole lineup. Our home is the 5th largest planet in this system. And get this, it's been sitting right here for roughly 4.6 billion years. But our system is actually incredibly diverse. There's a really stark contrast between our neighboring worlds. On one side, we've got the inner terrestrial planets: Mercury, Venus, Earth, and Mars. These guys are small, they're solid, and they have rocky surfaces. But then on the flip side, we have the outer Jovian planets: Jupiter, Saturn, Uranus, and Neptune. These giants are much larger, totally gaseous, and they actually lack a solid surface entirely, like nowhere to stand. Now, as vast as our solar system feels to us, it's really just a tiny speck in the grand scheme of things. Let's look just beyond our sun to our nearest stellar neighbor, Proxima Centauri. It sits 4.25 light-years away. Now, that might sound like a pretty small number in astronomical terms, but in reality, that translates to a staggering 40.2 trillion kilometers away from Earth. Let's slow down for a second, just to put that immense distance into a human perspective: 6,600 years. If we were to travel in a straight line at the speed of NASA's Parker Solar Probe, which, by the way, is the fastest spacecraft ever built by human hands, hitting speeds around 700,000 kilometers per hour, it would still take us roughly 6,600 years just to reach that nearest star. Think about that. That is longer than the entire span of recorded human civilization. Moving on to part 2, the Milky Way galaxy, our island universe. So zooming out to that island universe, the scale here is absolutely jaw-dropping. The Milky Way is a barred spiral galaxy featuring 4 main arms, and it contains an estimated 100 billion stars. The whole disk stretches roughly 100,000 light-years across. And just as Earth orbits the sun, our entire solar system is orbiting the center of the Milky Way. It actually takes our sun 250 million years just to make one single trip around the galactic center. And you know what? We aren't even downtown. We live way out in the galactic suburbs. Specifically, our solar system resides on a minor structure called the Orion Arm. Sometimes you'll hear it called the Orion Cygnus Arm. This structure alone spans 3,500 light-years wide and extends roughly 20,000 light-years in length. Which brings us to part 3. Searching for another Earth. The quest for life. Beyond our Milky Way, there are billions of other galaxies, and each of those has countless stars and planets. With all those billions of planets out there, scientists are actively hunting for conditions suitable for life. Enter LHS 1140b. It's an Earth-like exoplanet 49 light-years away. Researcher Ryan McDonald perfectly captured the excitement around this, calling it the best, most promising, exciting laboratory for studying astrobiology and habitability outside of our solar system. And it is so easy to see why astronomers are thrilled. We now know LHS 1140b has all the right ingredients. It's a rocky planet sitting squarely in its star's habitable zone, with temperatures that could actually support liquid water. Crucially, the James Webb Space Telescope confirmed it has an atmosphere to shield the surface from radiation. Plus, it orbits a quiet red dwarf star, which means fewer violent solar flares. I mean, finding an atmosphere on a rocky planet in the habitable zone, that is a massive leap in finding another Earth. Let's shift gears to part 4, mysteries of black holes, time and gravity warped. We're going to plunge into one of the greatest and, quite frankly, darkest mysteries of the universe. A black hole is a region where gravity is so incredibly intense that absolutely nothing, not even light, can escape it. The boundary of this point of no return is what we call the event horizon. But what makes this truly mind-bending is that black holes don't just bend the shape of space, they severely warp time itself. And this creates a total paradox depending on your perspective. If you are a distant observer safely far away, an object falling into a black hole appears to decelerate, turn red, and completely freeze at the edge of the event horizon. It literally never seems to cross. But from the falling object's own perspective, it crosses the horizon in its own normal time without stopping at all. It's the exact same event, experienced completely differently, just because time is being stretched to its absolute limits. Shifting from pure theory to actual observation, our modern telescopes are now capturing these massive cosmic engines in action. Recently, the James Webb Space Telescope spent hours just staring into galaxy NGC 4696, which is 145 million light-years away, by the way, to observe a supermassive black hole actively feeding. And what they witnessed was just a violent, cosmic feeding frenzy. The telescope captured an incredible 800 light-year-wide spinning disk of material. Inside this disk, gas is racing around at an astonishing 600 kilometers per second. They observed cool gas filaments funneling material inwards. This provides the strongest evidence yet that these black holes actually recycle their own fuel to grow, acting as the powerful, dynamic anchors of their host galaxies. Finally, we arrive at Part 5, the dark universe, the invisible scaffolding. As dramatic as black holes and billions of shining stars are, they lead us to the final and perhaps most profound mystery of our explainer today. Everything we've talked about so far, stars, planets, you, me, even the gas feeding those black holes, it's all made of ordinary matter. But scientists have discovered two invisible forces completely dominating the cosmos. On one side, we have dark matter. It's completely invisible, doesn't interact with light, but it exerts a massive gravitational pull. It basically acts as the cosmic glue holding galaxies and galaxy clusters together. On the other side is dark energy, which is this mysterious energy field that actually has a repulsive effect. It's causing the expansion of the universe to accelerate, pushing galaxies apart. And this brings us to a truly humbling realization about the total makeup of our entire universe. Dark matter and dark energy account for a whopping 95% of it. All the ordinary matter, every single star you see, every planet, every galaxy, and us makes up only 5% of reality. That means 95% of the universe is completely invisible to our eyes and our instruments. Which leaves us with this final awe-inspiring thought for today. What are we going to discover next in the unseen 95% of the universe? As our telescopes get sharper and our understanding deepens, the ultimate fate and the deepest secrets of the cosmos are still out there, just waiting in the dark. Thank you so much for joining me on this incredible journey. Keep looking up, keep asking questions, and I'll see you in the next explainer.